I went outside of my comfort zone with everything here.
Okay.
This motherboard is over $200, and it's RGB, and it's ASRock. I am concerned at the size of the box that motherboard is in, because that's a big box. So right. I certainly hope the motherboard's much smaller than that inside, and I've been tempted to open the box and look, but it wouldn't be live. That's right. So I have, everything you're seeing here is all sealed except this RAM. Here we go. It's funny, that, so they have like a gaming, a Z390 Phantom Gaming 6, a Phantom Gaming 5. Finding the Gaming 7 was actually quite difficult.
Okay.
I don't know why. Yeah, that's like the biggest motherboard box. Oh, and it's a big board. I hope, is it gonna fit in there? I hope it fits.
Now what size would you say? Because you have ATX, right? You have, what size of motherboard?
Oh, it's around a big foam thing, so that may be. Ooh, the foam thing is zip tied to the motherboard.
Oh, then you.
I need my wire cutters. There's a zip tie in each corner of the way that they pack this. I've never seen that before. Flip it the other way here so you guys can see.
Which one's here?
It's a good looking motherboard. I think that's why I bought it. I was really.
The wire cutters?
Yeah, the wire cutters, not the needle nose.
Yeah.
Thank you.
Just testing. Okay.
Did I pass?
Yeah.
But now we can remove this little protective plastic over the I/O shield. The I/O shield is built onto the board, which is good. It's got 2 Ethernet ports. Supports built-in video if you want to use video off your graphics card, though. I will say normally at this level, people would have their own graphics card for a gaming machine. This will not be used for gaming, and that's why there's no GPU listed. We're going to be using the built-in GPU on the processor because the person using this computer will be using it for business. And I do see on this board, underneath this heat shield should be a place for an M2 drive. Underneath this heat shield should be a place for an M2 drive. And right here, you see there's a little screw right there. That's for adding Wi-Fi. You can put a little laptop Wi-Fi in there. We'll start with the solid state drive. This is an Intel 660p. This is a 2 terabyte M.2 NVMe SSD, and it runs about half the speed of like a Samsung 970 Evo Plus, but it's also half the price. In fact, a regular SATA 2 terabyte drive often costs more than this. Why anybody who's got the ability to run NVMe would still be running SATA? You're spending more money to go slower. And the rest of this goes in the recycle bin. Now this can go either here or here. We'd have to look at the documentation to see if either one of these runs slower. Typically the one on top is the fastest one. It's also the hardest one to get to, especially if there's a graphics card installed. So I like to get this one out of the way. Also, this Intel M.2 drive, NVMe drive, only runs at about ×2 speed. So even if this one's a ×4 and can move data at 3600, you know, on some motherboards this one's like a ×2. If you're using like an Intel 660p or a SATA drive, don't waste your ×4 slot because this isn't going to run any differently. So what I'm saying is for this drive, it doesn't matter location apart from convenience. And so getting this one out of the way by putting it up here, that means if the customer wants to add more storage later, they can easily take the side panel off and get right there to put another storage drive in. If they choose to do that at some point in the future. We'll start by removing the heat shield, or heat spreader as they call them. M.2 drives do not require heat spreaders. Some people really feel like they need them, and other people like the aesthetic of, you know, just the way it looks, that it's hidden. Is that piece not going to come off by itself? I got to take this whole piece off. That's crazy. Something's locking it in there. I don't know if it feels like thermal compound that's kind of like glue. I don't see any missing screws. That's why I thought this piece would come off by itself. You see it's wiggling. This is where documentation comes in handy. But I feel like it should just, there it is. It was thermal compound. There's a wire running into this because this lights up, and there's a piece of tape here that's covering a thermal pad that's going to be on our M.2 drive that we're about to install. And there's a little rubber stand. I've never seen that before either. I guess that's there to support that heatsink when there's nothing underneath. I guess we leave it in. Can't imagine it's going to cause any harm. It's just an extra little support.
In quotes, I guess. Okay.
I guess. I'm guessing.
Okay. Yeah, okay.
I think we just
Yeah.
leave it there. I don't think you take it out.
Okay.
Honestly, I think
Yeah.
if you took it out, it wouldn't matter. But I'm going to leave it in because I don't think it matters. There's little indentations on each side. Hold it by the edges so I don't have to worry about wearing an anti-static strap. This is going to go in. You line it up, and then you push it straight in until you don't see those little gold fingers, and it'll sort of spring back and forth. When we put the heat shield back on, when the heat shield goes in, it holds the drive in for us. And we'll grab that heat shield, so that's a standoff there. And we'll put this back where it was. Probably a good idea to just get all the screws started before you tighten anything down. Don't over tighten, you want to just take these down till they're snug. And that's it. And that's 2 terabytes of storage installed. Now this other heat shield here, let's just open that up to show you what's underneath. You can add a second M.2 drive here. Just take out both of those screws. This should just pop right off. It's also got thermal tape underneath of it, which we're going to leave covered up. And you'll see there are 4 positions here. There's your M.2 socket. And the 80 millimeter has got to be this one. And what I'm going to do, because people always lose these, I'm going to, it's got that tape over it. Let's take the tape off. And it's weird. I'm not sure what they're solving. Maybe they just don't want anything grounding against it, but with that little, it's got another little rubber standoff there. I don't know how anything would make contact with those. That seems a bit over-engineered and kind of a pain in the butt. I've never seen a motherboard manufacturer cover up standoff holes before. So that should be the 80 position. And I'm not going to put a drive in here. I just feel like motherboard manufacturers should be installing these because, first of all, it's very wasteful to use a Ziploc bag, one for each screw and one for each standoff. Like they all have to be segregated. And what I'm going to do is I'm just going to put the screw in there, and then if the customer later on opens this up to add a drive, they don't have to go looking for the screw and standoff, which will be in this box, which, you know, could be years after they bought the system and they don't know where the box is anymore. So there's no harm in just putting the screw and standoff together. Just don't over tighten it. And put the heatsink back on. Which was what? This way, I think, wasn't it? Does that look right? Yeah, that's right. And then we'll put those 2 screws back in. So normally if you were building along with me and you weren't putting a drive in, you wouldn't have to remove this at all. I just wanted to show everybody what was under there. And then this M.2 right here says Wi-Fi on it, you see? And it's got a little tiny standoff right there, and I want to put the screw in there as well. So again, you can see there's a sticker over that. And if the customer were to add Wi-Fi, look, they could add Wi-Fi through a PCI Express card, they could add Wi-Fi through a USB port, or they can add Wi-Fi through an internal laptop style internal M.2 Wi-Fi card. So lots of different ways you could add Wi-Fi to this desktop computer. Here's the CPU, brand new in the box, 9900. You see the specifications on the chip right there. Now this does include a stock heatsink and fan, which we are not going to be using because on the Core i7 line and the Core i9 line, this is an i9 9900, the fans run too loudly. Now here's the CPU. This is like $500 in my hand, something like that. It's pricey. And the way we install it is I'm going to push this lever down and bring it out, just like so. Keep your fingers clear of that area. There's a corner cut out on that plastic, so we can lift that up. Once again, there are cutouts here for your fingers, and I'm going to hold it by the edges, so whether or not I wear an anti-static strap is irrelevant because there's no place for the static to go other than, say, the heat shield or places where they're intended for static to go. So you can wear an anti-static strap if you want to, but if you handle the parts the way I show you, then it's something you don't really have to be too concerned about. Now you notice there's a little gold triangle right there, and there's typically another little triangle in the socket, and I don't see it. There's also two cutouts. I don't know if you can see the little cutout by my fingernail, and there's one on the opposite side. So that chip is only going to go in one way, and typically the writing always faces the same way as the motherboard. So you see it says ASRock, and you see the facing, how that writing is facing you. And if you look closely at the CPU, if you can see if we can get rid of that glare, you can see the text on the CPU is also facing the same direction. And that seems to hold true on all of the Intel Socket 1151 boards I've ever seen. Make sure it's seated correctly, then we lower this lid, and then push this lever down. It's going to have a lot of resistance, and this plastic protective cover will pop up. There it is. We're going to put this away. We need this. If we have to send the motherboard back to the manufacturer at any point under warranty, we don't want to send it with our CPU installed because we may not get the CPU back. But you can't leave those pins exposed, or the motherboard manufacturer. All of them will say, because you did not include this, you voided your warranty. Have a nice day. So hold on to that and hope you never need it. We're using the Corsair Vengeance Pro RGB. This is 3,000 megahertz, 2 sticks of 8 gigs for a total of 16. And we want to skip a socket, but the question is, which socket do we start with? I'm going to refer to the owner's manual to see which 2 sockets I should use. If you've only got 2 modules, put it in A2 and B2. A2 and B2. So that's where we're going to go. On the board, it should be labeled somewhere. It should be labeled right up here. Can you see that?
Yeah.
It says A1, A2, B1, B2. And that means this is A1, this is A2, this is B1, this is B2. So we want to be in this one with the RAM modules. Once again, we don't have to worry about any anti-static discharge as long as we're holding the RAM by the heat spreader and not touching it anywhere where it's gold, then there's no danger of that. And this will just line in one direction only because it's got there's a little cut in the RAM and there's a little notch in the socket. We'll place it right there, and then using thumbs, one side and the other side. You'll see this side doesn't open. The reason this side doesn't open is they're afraid if you put a big old graphics card right there, these won't be able to open. They'll get in the way of the graphics card. So some motherboards on one side near the graphics card, it won't open. Others do. So it just depends. I don't want to see people hammering on that one, trying to open it when it doesn't open. And then finally, we'll grab that other memory module. Again, rotate it into the proper orientation. Slide it gently into its, hold on, I gotta change position. There we go. That's 16 gigs of RAM installed, our CPU's installed, our storage is installed. Now, I've never seen this cooler before in my life. I'm very curious about it. It looks very promising. And I've always really enjoyed the quality, appreciated the quality of Silverstone's products. So I expect this to be more of the same. Setting up a water cooler is typically a little more time consuming and more cable management than an air cooler. So be prepared if you order one. And they typically only last between 4 to 6 years and need to be replaced when the pumps die, versus an air cooler, which, you know, if a fan dies, you just change out a fan. We're going to need to use this backplate. You'll notice the backplate has these little humps on it. That's going to be the part that goes towards the motherboard, and that's to ensure the metal doesn't contact metal on the back of the board. So you don't want to put it on this way. You want to make sure that this part with the bumps or the humps, those are going to go towards the board. Down here, we've got 8 screws. These are for holding the fans into the radiator. So these go over here with the fans. Okay. I was confused because I didn't know the little diagram. It's kind of hard to tell if we're using these or these. Now these have a little Phillips head on them, and these have no head on them at all. They just have a flat edge and they lock in. So those are the ones we're going to need. The only decision I have to make right now is whether or not to put the radiator in first before the board, or if the board can go in without getting in the way of the radiator. So, well, let's open up the case and we'll take a look and see what's going on inside there.
Take a little look-see, okay?
I'm going to lay this case flat so we can get the motherboard put in.
And we'll switch to our...
And I'll tell you something else I'm going to have to do. Once this motherboard goes in, I am not going to be able to reach these connectors.
Okay.
I can tell you that right now. So because this case, it's a little bit small, it's a little short. Other larger cases you won't have this problem with. And not that it's really a problem, but a lot of times you can build a computer in any order.
Okay.
We have to watch our order now. And so for that, we need to get the power supply out of the box and get the cables that we're going to need now and plug them into the motherboard now so we don't have to do that later. Thank you. So this is the BeQuiet StraightPower 11. 650 watts, and it's supposed to be quiet. Here's what the power supply looks like. Here's the back of it. There's our specifications if you guys are curious. Now I'm not going to plug this into the power supply. I need to plug it into the motherboard. Like I said, this area is going to be difficult for me to get through. And Gigabyte likes to put a fan header up here, but ASRock doesn't. So I won't have any reason to get up in here once that
Radiator.
Cooler is put in. Yeah, when the radiator is put in. Thank you. And I hope this RAM won't get in the way, because this RAM did get in the way of a different build, which is why I have that RAM. Because you see how tall it is? So we're going to find all this information out as we build.
Live, which is great.
Now, of course, you can do research on the internet and figure out the height of the parts, the depth of the case, the size of the board, the depth of the radiator. You can do all that in theory. I'm sort of a wing it kind of guy. And I have lots of spare parts, so if we have to swap the RAM out and go with something non-RGB, then we will. Hopefully everything will go together well. So hope for the best.
I like a good mystery. Okay.
Yeah, right?
So
well,
it
won't be a mystery very long.
Right.
We will have all of our answers here very soon. So I'll set these other cables back here just to get them out of the way.
You'll pop that
And
cable
in fact,
out.
I'm going to move the power supply because we don't need that yet.
Yeah.
So all I have to do here is on the end of this cable that says CPU, it says P4, P8. We'll keep those together, line it up, and plug it straight on. Now in theory, I actually don't have to do this right now. The order of events is really important here. If I put the motherboard in without the radiator in the way, I should be able to reach in and plug that in, no problem.
Okay.
Then run the wire behind the board, then put the radiator in, and see if that radiator is going to interfere with, or
Okay.
the RAM rather will interfere with the radiator.
Okay.
Now I'm nervous. You see the RAM is quite a bit taller if you look at where the I/O shield is. It's a good ½ inch. It's pretty big difference.
Let's take a chance.
Well, we're going to
Yeah,
find out
yeah,
one way or
yeah.
the other. So, but that's what's going on in my mind. There's a little anxiety, but we march forward and see what happens here. So what I'm going to do is spin this around here.
You want me to get the camera 3?
No, what I'd like you to do is just hold that in position for me, and I'm going to grab this and set it in. Set it in place. Make sure the fan cable's out of the way. Wow, that fan really, it's almost advisable to take this fan out to get the motherboard in. It's a very tight fit to get underneath the fan with this big I/O cover. So with this motherboard in this case, sort of a very tight fit there. Yep. So there's 1, 2, and you shouldn't tighten the screws all the way down like I'm doing right now, because if you need to wiggle the board a little bit, the board won't wiggle with the screws tightened. And the reason you might need to wiggle the board is to get it to align with the standoff underneath if it's not exactly straight.
Uh-oh.
Oh, we trapped the fan cable under the board. The fan cable ran down here and it got caught under the board. So all these screws have to come out. But these are the right screws. These are, different case manufacturers use different screws. And these are just standard computer screws with the hex head on them. Nothing special.
Allow me to hold that. Okay.
Yeah, it'll be out of the way
Yeah.
now. Can I get on the center post? Okay, we'll try this again.
Take 2.
And call me in the morning.
Yeah.
Let's see if the top lines up. Let's go up here. Okay, that's 3. I want to go in this opposite corner because this is always a tough corner to get.
Okay.
The back is all lined up correctly here. That looks good. We'll pick the case up, bring it on its feet. And now you can see what we've got
Beautiful.
going on there. Will you take that for me? We're going to need it again soon.
Yeah, that's true.
And then we've got 1, 2, 3, 4, 5, 6. How many extra screws? 5 extra screws for something else. I don't know what. And this is that rear power cable. And that's why I say getting that fan out of the way. I don't know how well you can see that, but if we zoom in there, if you look at where the top of that I/O shield is, right up here, and where the fan is, I can't even get a fingernail underneath that.
Yeah. Ideally, like Carey said, it would have been better to remove that fan, put the motherboard in, put
Yeah,
the fan,
and then we
put
wouldn't
the
have gotten
fan
trapped
back.
underneath
the thing, but
the cable, yeah, underneath the board.
that's what you learn live.
Now, Mike, I'm really curious though if this is going to fit in here without hitting the RAM. Oh, it is so close. Wow. The answer is yes, I think. It is hitting the top of the RAM. Wow. So, okay, this fan right here is hitting the corner right about where that band is on the RAM.
Okay.
It's hitting right there. This is a problem I had with the RAM. Regular RAM won't interfere, but the RGB RAM, because of its height, let's tilt that down again. Here's the problem. If I put this in and the customer has to do anything with the RAM, they're going to have to take the radiator out, which seems silly, and it's going to be tight. Like they won't be able to put any more RAM in and they won't be able to take any RAM out with this in the way. We can put the cooler in here, which is sounding better and better to me.
And keep the RAM.
You know what we could do? Yeah, and keep the RAM. Yeah, because it wouldn't interfere with the RAM that way. Whether we push air or pull air through the cooler doesn't make much of a difference as far as the efficacy of the cooler goes. But if we were to put these two fans here and then run the screw through here, that'll secure the radiator at the same time. And then we'll push hot air into the case. Well, it's not hot air. We're pushing cold air from outside through the radiator that's hot. So the hot exhaust air through the radiator then is going to blow across the case. That's not the best scenario, but even if I change the RAM to non-RGB, they're still going to have a little difficulty if you ever have to get in to release the RAM, because that fan hangs down right to about here. So I wish this case was about another ½ inch taller. So this person really wants the RGB bad.
Then your question's answered. Keep the lighted RAM and put the radiator up front. So that's, you've got to get rid of that fan then. There you go.
So all I'm doing right now is just removing that front fan. So we have to use this cooler. We have to use this power supply, and we have to use this case, because those manufacturers were gracious enough to send those materials to me. And rather than just review them, I thought, I'm going to build in them, because that's the best review, is real life. And now we've run into this little stumbling point, which only exists not because of the cooler, but because of this RGB RAM. However, and I want to reiterate, if the case were ½ inch taller, this wouldn't be an issue. This is not a unique issue for this liquid cooler. Any 240 millimeter cooler is likely going to have that interference issue unless you get some really low profile fans on it, which is not standard. Can the radiator go on the back? No, it cannot. The only place the radiator can go is on the front or the top. Some cases will allow the mounting of the radiator on the bottom, but that's not going to happen here. Typically, if you have a really big case, like a Cosmos 2 or something, there's lots of space for radiators. But on the smaller cases, the smaller the cases, the more limited your options are. Oh, we can go all the way up here.
Okay. Yeah. There. Yeah, I got you.
That'll work.
Okay.
We just have to go way up to the top.
Okay.
Okay, now I need to hold this in place. Hold it exactly where it is, right there. And I'll grab the fan. And I guess I want the cable, I'm trying to think which way. We want this mounted this direction. We want to draw air in.
Through, okay. Gotcha.
And the screw will go this way. Fan cable's going up that direction towards the wiring management area. All right, I'm going to bring these, hand that to you. Will you pull that through?
Say when.
Keep going, you got a long way. Right there, and then there's another one for you, right there. And this has got to go. Go ahead and pull it, keep pulling. There you go, right there, perfect. Okay, that's what the final looks like there. This all started because I wanted to plug this cable on, remember?
Yeah.
But now there's nothing in the way to worry about that. We can get it out of the way. We'll just run this up through the corner here. And then I'll just, let's see, rotate it this way. Go ahead and pull on that slack for me if you would. We'll just pull it all the way through. Keep pulling, pull, 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 pull. Okay, so let's do this. Let's take this bracket. Remember this?
Yeah.
These internal sides, these are for AMD. It even says AMD right on the top of the bracket. So what we do is we take the bracket, we put the screws through the bracket, and then put the washer on it. And that's going to hold the screw in place. What position does it need to be in now? I can't remember. I'm going to go right back to square one on this. Next. See what I'm saying? There's a outer one and an inner one, and I wasn't paying attention. So before I go any further, let me just check if that's going to line up. See how that's holding it for us?
Gotcha.
It looks like they've got to go on the inside. Of course I'm going to get it wrong. I'm going to do it wrong every way I can. Hold on, Mitch. Let me make sure I've got it in the right place this time. Yes. Yep. So it's going to look like that. See, it's a long, if you put it all the way at the end for this socket, the screws won't align. And you want to make sure, or you'll have to redo them all. So that's why I wanted to check it early. There we go. Now we should be able to put this on here.
Oh yeah, you got a lot more screw there.
Is that so?
Yeah, not to be graphic. All right. You still want to?
Oh yeah, there's a lot more.
You still want to lay it on its side? Or you want to try it like that?
Well,
I
go ahead and hold it
gotta
back in there for me.
I gotta hold it. Hang on. I'm holding it.
Okay, put that there, that one there, that one there, that one there. Take this and put it on here. I was thinking about the issues. Mitch and I were struggling with the Silverstone PF240 liquid cooler. I've got to tell you right off the bat, I was really upset at the lack of detail in the very sparse directions that come with the cooler. And I was even upset at the factory video from Silverstone that shows how to install it, because I felt like they went through it too quickly. My videos, we do everything a bit slower, we do it at a real pace, and I feel like that's a lot easier to digest and better to set an expectation of how long something should take. And Mitch and I were working on this way too long. And the first rule of thumb that I didn't even follow was, when you're struggling, you're doing something wrong, stop and reevaluate it. Look for another approach. Maybe you've got a part on upside down, or maybe you're missing a part that would make that easier. So while I was struggling with this cooler, it was because this back plate, which can go on sideways, or it can go on 180 degrees, or both, and the directions, well, they kind of tell you which way to put it on, but they do it in such a very sparse way that attention to detail and focus is extraordinarily necessary, because the directions don't go in your face and go, it has to go like this. That's what instructions need to do. They need to be very verbose. They need to have a lot of words and a lot of pictures so that there's no confusion. I think the directions for the Mugen 5 they're just one page and they're all pictures, and you really don't even have to read the words. That's how good directions should be. However, as long as directions remain as terrible as that, I have a reason to make videos where I can show the proper way, so when people buy this stuff, they don't have to suffer through that amount of focus and attention to detail that those instructions are requiring you to do. So I've installed countless liquid coolers before. How different could it be? It was very different. Furthermore, it didn't really specify which of the slots went into the lineup for the CPU. So here's the gist of it. If you want to buy a Silverstone PF240, which I can't tell you if it's good or bad at this point, but the installation process is a lot simpler than I made it out to be through my lack of experience with this product. First and foremost, this metal backplate needs to say the opposite of what you're installing it for. You'll see that that backplate says AMD right here. AMD. So you think this backplate is on backwards. And these little bumps that stick out that prevent this metal plate from touching the back of the board, I would have thought for sure that that's on the Intel side, because that's what I'm accustomed to seeing from other manufacturers. And as with regards to these long slots, there's a top, a middle, and a bottom. And these screws, these go into the middle part of the slot in order to line up for a socket 1151. So if you're going to build an Intel socket 1151, which is, any of the modern i3, i5, i7s, i9s, well, some of the i9s, you need to know that this backplate has got to say AMD. Those screws go into the middle position of this elongated hole, and you will use a little washer that they call a spacer that holds that screw in place so you can install this without the screws all falling out. Then what they call standoffs are actually spacers. And then those spacers go on, and if you've installed it correctly, the thumb screws will go on without any effort required from a second person, as Mitch and I struggled. Now, when it comes to the RGB, there's two different kinds of RGB wiring. One's ARGB and one's, I can't think of the other one. But one has 3 pins. Wait, let me zoom you back in so I can show it to you. On the ARGB, it's sort of a universal, looks like there's 3 pins. And your motherboard will support this or the other format. It depends who makes the board. I think Gigabyte is different than Asus on that. But this cooler allows for either standard. Now, look at all the cables we got to deal with here just for the RGB. This is nothing but lights and more lights. And there's another cable around here for more lights. This is all additional cabling that's going to have to be done on this system. Oh, not this one. I'm sorry. These down here. These are the. Zoom in again. These right here, as you can see, are the RGB. And there's a male and a female, and it's meant so you can just daisy chain them all together like Christmas lights. And you just, don't plug in the ends. That's all. When you get to the end of your chain. So for this pump to work, what we want to do is we want to plug the pump into the CPU optional header. Now this plug has 3 wires on it, just like any other CPU fan. Well, it could be 4 wires, but this one has 3. And on many modern motherboards, they will have a separate header for the all-in-one pump. The all-in-one pump needs to be running at full voltage at all the time. You want your CPU fan voltage adjusting so that your fan is running slower and quieter when the CPU is idle. And then you want your CPU fan to crank up as your CPU gets hotter. But with a water pump, you just want it running all the time. Now, usually in the BIOS, you can go in and you can say my CPU fan is a water pump. So you tell the motherboard to stop varying and don't worry about it. Internally on this, I don't think it really matters which one you plug it in. I think it's going to pull 12 volts off of it regardless of what the motherboard's doing. However, what I don't like to do is I don't like to give you specific instructions where you can get away with installing it a certain way with this specific model, but not with another manufacturer. So what I'm giving you is a general overall terms of how liquid coolers work overall. And while there are individual differences with each cooler and where you can plug a cooler in, depending on how the manufacturer designed it, I want to teach you the way that is sort of the standard. And if you always follow the standard way, you won't have any problems regardless of whether or not the pump will work on the CPU header or not. If you always plug it into your all-in-one pump header or your CPU 2 optional fan header, that also doubles as an all-in-one. And you can often go into the BIOS and you tell the BIOS that header is an all-in-one. You don't have to do that with all coolers, but it won't hurt you if it's not necessary to do it anyway. So this one right here is going to go on to the second, or what we call optional CPU fan header, which is right up here, like so. And then right up here is our main fan header. And the reason I'm not using that one for the pump is I want to use it for these 2 fans. What I did mistakenly is I plugged the fans onto the motherboard. Let the motherboard control the fans as the system heats up. It'll turn one fan on or the other fan on. But then that kind of ruins the RGB look. We don't want these 2 fans running at different speeds. These need to be in synchronicity. They need to be running at the same speeds at all times for the visual symmetry of it all. So I'm going to unplug these fans where I mistakenly plugged them in down here, because remember, we're building this not to run the quietest system, although it will be quiet. We're building it to be colorful. Now, the problem is we have 2 fans and 1 fan header, right? We only have 1 CPU fan header. In the box that came with the cooler, there was a fan splitter that I scoffed at. We don't need that. Well, no, we do need that, because that fan splitter is going to take that 1 CPU fan header. Here's our extra cooler parts. Here's the splitter right in here. Another reason why I keep everything together. But all we need to do here is take the 2 fan power cables that are coming off the front of this, that's RGB. Here we go. And we'll plug each fan into the fan header here, into the splitter, I mean. So there's one. Where's the other one? Oh, right here. Here's the other fan plug. See, all these cables, things get confusing, as you can tell. I'm already confused, more so than normal. Now, with these 2 fans plugged into the splitter, this will go on the CPU fan header. We definitely want the system to know there's a CPU fan in it. Some motherboards will power up with an error message saying no CPU fan detected. So we definitely want to plug a fan in there. So we'll just run that up there for right now. We'll bring it around here, and right up next to the CPU optional, which is where the pump is. And by the way, on most motherboards that have a CPU optional, the headers are usually fairly close to each other, usually within an inch or inch and a half of each other in most cases. Now, it's very difficult for me to see in here. It is very, very dark. Let me just plug it on real quick so we can move on. Now, on this motherboard down here, it's offering both types of RGB output on this ASRock board. So we're using the ARGB is what it's called. And each fan has an input and an output. So each fan can accept RGB and give RGB to something else. Because once it takes up the plug, how do you plug another plug in? So you'll see you've got a female in the middle and a male that's got a protector on it here on the end. And so since this fan right here is already plugged in to the RGB on the motherboard, then the male connector on this fan can plug into the female connector on this one, like so. Not quite sure how well we're going to pick that up, but those two just go together like that. And then this one here can then go back up through here, because our water block also has RGB that needs to be fed a signal. And so for right now, I'm just going to do this a little sloppy and plug in. We're going to take a little cover off and we'll just plug in the male end from the other fan into the water block. And if you don't want the water block to light up, or you don't want the fans to light up, just don't plug those into the motherboard. Don't plug them in at all, and just wire time. And you just wasted some money for paying for something you're not using. But hey, it's your money, whatever. Now you can see what a bit of a cable mess it's already becoming, but that'll be something to deal with later on. For right now, we're not concerned about how it looks. We want to make sure that it works. And we're getting very close to our first power on. So it's time now, we can put the power supply in. I have the power supply back here. Right there. Don't tighten them down, just get them started so that you can move this around to align it properly. And then I like to give the screws a little bit extra of a turn on the power supply because of its added weight. I don't want it to vibrate free, and also because of the fan that's turning. It's probably unnecessary. The clutch level of 3 is what I have this screwdriver set to, as you can tell right here, between 2 and 4. So it's a pretty low clutch level, and it's to make sure I don't strip any screws or break any heads off of the screws. Then this will slide in with the fan facing down, because the fan is going to draw air into the power supply and then blow it out through the back. None of the air goes into the computer. It's all contained in this box. So if you do have the filter, you can simply lift up the back of your computer or feel for it. Depends who the case manufacturer is. Visually inspect it. Sometimes you can just feel it. This one looks like it's going to come out the front. If I turn it around this way, that's a big old filter right there. And if you forget that it's there, or you're not good about cleaning it, then I suggest you don't use it, because you're better off with no filter than a clogged filter. That installs the power supply just that easily. There's our big motherboard power cable, and we can run that. I'm trying to figure out how I'm going to cable this bad boy here. That's going to be in the way. Oh, I see. Okay, so we're going to take this. There's a pretty unique cutout design here where you see much less of the cable through this design, where we come in kind of sideways through here. And that way this piece is covering the big gaping hole. Like when you see me work on the Corsair 200R, you see those big cable management areas fully exposed. But that, of course, is not a windowed case. So I'm just going to pull this through as much as possible, because I need all the slack I can get to plug it in. Once it's plugged in, I can pull the slack back out the other side. So it's important you do that part in the right order. You don't want to worry about your cable management yet. At this point, you want to make sure everything's plugged in securely in the right place. You haven't forgotten anything. Make sure everything works. And your last thing is to cable management. It's sort of like you wouldn't want to build a car from scratch and immediately go and put a really nice paint job on it before you've even test fired the engine and determined you have to take everything back apart again, potentially damaging the paint in the process. Okay, that's on there. Remember, we already installed the 8-pin, so we have to come around here. Once again, find a way to route this where it's not going to get tangled up. And it's very difficult to see, very difficult, because this should have gone on first, but if this went on first, I wouldn't be able to take the power supply out to put on this one. But because I put on this one, I can't see behind it, because the design that they put all of the modular plugs vertically, one behind the other, means you have to work your inside to outside, because we cannot get at it from this side at all. This piece does not appear to come off. It looks like it's riveted in there. So the only way I can get any more room or visual is to take out this hard drive tray, which we don't even need for this build. and it's just 2 thumb screws. That gets it out of our way. Hey, lo and behold, look at all this room I've got now, and I can see in there. It's going to go right there. Just plug that in, right in there. Now we're getting very close to being able to do our first power on self-test. The pump is now installed correctly, and I would love the opportunity to install another one of these pumps and make a how to install the Silverstone PF240. Because I think it's going to come in handy for anybody who wants to install one of these. Unless you're much better at interpreting the instructions than I was, which pretty much probably anybody is, to be honest. I'm in a hurry, and I have a lot of experience, and I believe anything I'm doing should be similar to something I've already done when it comes to building or repairing a computer. So coming back around, we still have the front port audio to hook up. Front port audio is right here, and that's going to go down somewhere in the corner here on the front of the board. So we're going to bring it in. Where can we bring this in here? Oh, it's nice that they've given us cutout. Ow, I just stuck my finger on that pin. Okay, there's cutouts down here at the bottom, so we can bring that in all the way over here, and the audio port is just the last connector. Like I said, on ATX motherboards and micro ATX boards, should be right in this quadrant, this lower quadrant of the board somewhere. Can you see if I drew blood? All right. So once again, I'm going to try and route it away from the other cables that I'm going to have to deal with later, so I won't have to rerun it again. Now we can pull the slack back out, and then it makes that look nice and tight. This rear case fan is already plugged in. Again, I've left the wire tie on it. I'll do the cable management later on there. And then just the power switch at this point. We're going to be able to turn this thing on here in just a moment. So here is one of the easiest front port headers you're ever going to have to use. And that's because this case is a bit sparse when it comes to buttons and lights. Typically, you have 4 cables for a front case panel, and that's going to be your hard drive LED, power switch, and reset switch. Well, on the Pure Base 500, for whatever reason, BeQuiet has decided that you don't need a hard drive LED, and that bothers me, especially on a case that's designed with RGB. Why would you take away lights? And they decided nobody uses a power switch, nobody uses a reset switch anymore. And I can go with that. That's fine. You don't need the reset switch. But when you steal my hard drive LED for a $100 case that's meant to have lights on it, it doesn't make any sense why you would find an excuse to remove a light. That's the whole point. So that bothers me. I also, as a technician, like to see the hard drive LED when I'm diagnosing. If I think a system's locked up, if the hard drive LED is blinking on and off, I know there's something going on. If the hard drive LED stays on or stays off and it doesn't blink or anything, that would suggest to me the system's locked up. So not having that is robbing myself of information. So I'm going to just bring this in down here. It should be able to be on, should be a hole right about there. And then we'll bring that around. And here it is. Oh, there's also a USB 3.1 header up here for cases that support USB 3.1 with a USB 3.0 and another USB 3.0. That's really nice. And I should be done with this hard drive tray, so we can plug that right back in. Once again, some stuff you have to only go in from the back because of this design. We'll make sure cables are all out of our way. Now, we can also, we're going to leave this top off because we want the, oh no, this top can go back on. That can go back on. This was the fan we removed that we're not going to use. This is a plate that goes behind the motherboard, if you recall. It goes back here. And it's these two. I had to take it off in order to put the bracket on, but now that the bracket's on for the water pump, this can go back. It goes, trying to see which way this goes. It goes like that. There's two little tabs that go into the slots, and then this will close down. And then that single screw will secure it. This has a foam pad up front for noise dampening. And the way it's going to be able to draw air in from here is it's got holes all throughout the sides and bottoms so it can suck air in. Whenever you see a case that appears to have a solid front and you think it can't breathe from the front, you don't understand the engineering behind it. I've yet to see a case that has a solid front. They always have space for air to be drawn in. It's more subtle and hidden for the aesthetic of it. But it's not going to be starved for air, despite what you think. Starting to look like a computer, right? Look at that. We'll clean up that mess once we know everything works. So let's plug it in and turn it on and get Windows installed if everything's good. And we'll start by hitting the switch on the back of the power supply to the on, and you'll see the RGB lights already starting to come on the motherboard. This fan right here is kind of blocking the I/O cover. I was checking to see if there was plastic on there. I guess not. And then right over here, there's lights. So even though the system is off, there's still power flowing through it, and that's why it's important to flip that switch off on that power supply or to unplug it from the wall entirely anytime you're working inside of the computer. Here we go. Powered on. Colors. Colors. Ooh, look at those colors. And then let's go to camera 2. See if we get any video out of this thing. There, that's better. I think it was in like 4K mode or something, and only a quarter of the screen was being broadcast out. I want to make sure I can feel something moving through these pipes. That's the only thing about liquid coolers. If I can't see the liquid, how do I know it's moving? But there's a little vibration to the pipes. So the pipes, they are a coolin'. I guess we can install Windows 10 right now. I've got Windows 10 on a flash drive. You can make Windows 10 on a flash drive completely for free. Just Google the Windows 10 Media Creation Tool. Download it and follow the steps. You need an 8 gig or larger flash drive, and I recommend you spend $15-20 on a fast flash drive unless you've got a lot of time on your hands. This will install Windows 10 faster. Next, install. Looks like we don't have any more updates here. So we can go to, if we type in Intel SSD Toolbox, because the drive doesn't come with any software. You have to download it. So just go to Google, type in Intel SSD Toolbox, and we can get Intel's NVMe driver, and we can get the Toolbox software. So let's close that. I'm done with it for right now. Go back to where we were. We'll get that NVMe driver, which is this file here. I'll hit download, accept the license agreement, and again, I don't have to save it. I can just run it. And we'll click next, accept the license agreement, next, next. I can close that window. I'm done with it. We're going to have to restart the computer. For any NVMe driver, whether you see me use Samsung or Intel, that driver has to can only go into effect after Windows is restarted because you're using an NVMe driver right now, and it can't replace it while you're using it. Next. So I've got my flash drive with my custom tool on it, which, again, there's a link in the video notes below the video. If you want to purchase it, it's $10, and this is nothing magical. You could do everything that I'm doing with it by hand. This just does it a lot quicker, and it does it without forgetting anything, right? So I copy it off of the flash drive onto the desktop. I always do that. And then I double-click it, click yes. Up under options, I can check for updates. There's all free updates. There's no updates available. That's version 1.3. All these options are automatically set based on your configuration. So all you have to do is hit apply. You will see error messages where it says access is denied. That's normal. It's just turning off drive indexing. It's nothing to worry about. And you can right click on any option to flip it the other way if you don't like those preferences. We have to restart for the preferences to take effect. All right, I'm going to go back to my flash drive. Oh, what's going on down here? What's this exclamation point for? Yeah, wants me to keep creating a Microsoft account. All right, we'll go back to the flash drive, and we're going to bring over, in PC testing software, Prime 95 26.6. We'll drag it out to the desktop. And I want HW monitor. We'll drag that out to the desktop. Crystal Disk Mark, we'll drag that out to the desktop. CPU Z 1.91. These are all portable versions. None of these have to be installed. So they're easy to run, do what I need to do with them, and then delete them off the desktop with nothing in the registry or anything. So first thing I want to do is run Crystal Disk Mark. We should see about 2,000 megabytes per second on the reads and writes on the Intel 660p here. So we'll do all the tests. Let's see what this comes out to. All right, I'm going to get rid of that, and then let's bring up Prime 95. So the CPU has 16 cores, or 8 cores with 8 threads. Again, way overkill for this customer. And if we look at the current temps, they're ridiculously low. Like, this is ridiculous. They're currently under 30 degrees Celsius. That's crazy cold. The minimum value is here in the center, and then the maximum value is here on the right. Based on that, this cooler is doing an amazing job. So let's run Prime 95, which puts an unrealistic workload onto the CPU for a full 15 or 20 minutes, I don't know. We're just going to hit OK, go with the default values, let it run all those cores at 100% without a break for a breath. Imagine holding your breath for 15 minutes. Like, if you can hold your breath for 15 minutes without passing out, I'm pretty sure you can hold your breath for 3 minutes and it won't be a problem. Excuse me. This is really what this is about. This isn't about benchmarking it to see if it can run colder than anybody else's. This is benchmarking it to see if the customer were to put an unrealistic workload on this for an unrealistic amount of time, that they won't have an issue with the computer thermal throttling and then reducing its performance. So I'm going to start my clock because I forgot to, and we'll let that run for 15 minutes, maybe even 20. We'll take a look and see how things progress. But so far, looking on that right side of maximum temperatures hit, this is really impressive. We're about 17 minutes into the test right now. We even hit 60 degrees centigrade. This may be the coldest results of any test I've ever done so far on camera with an equivalent CPU. I mean, it's they're not always all the same, but whether I'm using an 8700 or a 9700 or a 9900K or a 9900, they're all sort of in the same, they're not exactly the same, but they're all sort of in the same area. Like I said, they'll typically get into the 70s, all of them, when they get pushed this hard. We're not even into the 60s. So that's crazy. That's absolutely crazy. So we're going on 20 minutes. I'm tempted to let it run a half an hour. Why not? Let's go another 10. I want to see if we can crack 60 degrees centigrade, because the longer Prime 95 runs, it gets through a series of tests and it starts to really start pushing and hammering on the system. And it's such an unrealistic workload that we're at the point of ridiculousness. But because it's breezing through it without so much as breaking a sweat, I'm standing here a bit dumbfounded as to how it's doing it without. Look, if this was in the low 70s, I'd be ecstatic. Imagine how I feel right now. We're over 10 degrees less than that. That's crazy. I'm just debating, should I put the other 2 RGB RAM modules in it? Really think I should. Yeah, let's do that right now. Let's go ahead and shut this down. All right, now we'll flip it back on. Hit the switch. Twice as much RGB. Yeah, you think that'll be enough RAM to surf the internet? System's pretty much good to go. I'm going to have to activate Windows on it with a license code. And to the community as a whole, thanks you guys for being kind and supportive and friendly. Thanks so much for watching. And until then, bye for now.